An even more interesting set of examples, however, is that we can use these trigonometric identities to transform one side of an equation to be exactly equal to the other side. And this happens quite a bit in trigonometry. So how could we use these identities here? Well, in example A, we're told that the cosine of the angle theta times the secant of the angle theta should be equal to 1. How could we verify that that's true? Well, we can go to our reciprocal identity. And how about this one right here that says, well, when you have the secant of theta, it's the same as 1 over the cosine of theta. So algebraically, we actually have the cosine of the angle theta, and we're multiplying that by 1 over the cosine of the angle theta. And to show that that's equal to 1, we would simply note that any quantity divided by itself other than 0 is equal to 1. Cosine of theta over cosine of theta is equal to 1. And if we're assuming that theta is between 0 and pi over 2, that's true. How about this one right here? We've got 1 minus sine of theta times 1 plus sine of theta equals cosine of theta. Well, sometimes we have to do a little bit of extra algebra right here. So let's do that. If I were to do the algebra, that would mean I might use my FOIL method and multiply these two quantities. I've got 1 when I multiply my first terms, and I've got 1 times sine of theta, so plus sine of theta, minus 1 times sine of theta, minus the square of the sine of theta. Yeah. By the way, this should say cosine squared theta, and I regret the fact that I did not type it in there correctly. This is a cosine squared theta in this problem. Okay, anyway, sticking with the theme, plus sine of theta and minus sine of theta, well, they're just going to subtract out. The other thing to note is that sine squared theta is the same thing as sine of theta. In other words, this notation, sine of theta squared, we write as sine squared theta to show that sine of theta is multiplied by itself, and that's going to give us cosine squared theta. Well, if I go right here to this identity, right, 1 is equal to the sum of sine squared theta and cosine squared theta, so I could just take this 1 right here and rewrite it. I'll have sine squared theta plus cosine squared theta minus the sine squared theta, and we should result in cosine squared theta, and of course we do, because these two terms now cancel each other out, and every term on the left-hand side equals every term on the right-hand side. And so that's what we wanted to verify, and we're done with this one.